Today we're going to talk about complex numbers. So a complex number is a number that can be put into the form a plus b I, where a and b are real numbers and I is an imaginary number, where I squared is equal to -1. Complex numbers are used in many scientific fields, including engineering, electromagnetism, quantum physics, and applied mathematics. So we know that an imaginary number isn't a real number. So that means that I is equal to the square root of -1, or I squared equal to -1. So we know that complex numbers in the form of a plus bi can be added, subtracted, multiplied, and divided. To add or subtract complex numbers, we combine the real parts together and the imaginary parts together. For adding them, here's an example. 2 plus 4i plus -7 minus 9i. We add the 2 and the -7, which leaves us -5, and then the positive 4i and the -9i will leave us with -5i. Now we'll move on to subtraction. We'll start off with 3 plus 8i minus 8 plus 2i. So what we're going to want to do is distribute the minus sign in the middle through the right side of the problem. So 3 and minus 8 will leave us with -5, and then distribute that to the 2i, that'd be a minus 2i, so that will leave us with plus 6i. Now we'll move on to multiplying complex numbers. So complex numbers are multiplied in the same way as polynomials. All terms of one complex number must be multiplied by all terms of the other. Now remember that I squared equals -1 and use this to simplify the result. So, as you know, to multiply a polynomial, you may use the acronym FOIL for first, outer, inner, last. So first, we'll do 5 times 4. That gives us 20. And then we'll do 5 times 3i, minus 3i. So that will give us minus 15i. Then we'll do 2i times 4, which will give us 8i. And then we'll do 2i times a minus 3i, which will give us a minus 6i. Excuse me, a minus 6i squared. So now we know that I squared is equal to -1. So we can rewrite this as 20 minus 15i plus 8i minus 6 times -1. So we'll combine our like terms. So 6 times 1 is a positive 6. There's a positive 20. So it'll be 26. And -15 and a positive 8 will leave us with a minus 7i. And that's how we multiply complex numbers. Multiplication of complex numbers. So, just like the last problem, we'll use FOIL. 3 times 3 is 9. 3 times minus 5i is minus 15i. And then we'll do 5i times 3. We'll get plus 15i. And then we'll do 5i times minus 5i. So that will give us a negative 25i squared. So, just like before, we know I squared is equal to negative 1, so that will turn into a positive 25. So we're just going to combine like terms now. So the 15i's cancel out, and then 9 and 25 is 34, like so. Since the 15i's, the negative 15i and the positive i cancel out, be 9 minus 25 times negative 1. And turn it to a positive 25, leaving us with 34 as our answer. So you can see with multiplication, we could just have an all real number answer. So now we'll move on to dividing complex numbers. When we divide complex numbers, the result should have no complex numbers in the denominator. To divide the complex numbers, multiply the numerator and the denominator by the complex conjugate of the denominator and simplify. Be sure that the answer is in standard form. I'll write it down just so we remember. So here's what the problem will probably look like when we get it. We'll just rewrite it so it's easier to do. So we'll multiply the complex conjugate so we have no complex numbers in the denominator. And again, we'll use FOIL to get the next part of the problem. So as you see, when we FOIL it out, that's what we get. Now, we combine like terms. So we've combined like terms, and now we have to turn the I squared into a negative 1 and continue the problem. Now, all we have to do is remember to put the answer in a standard form, like so. And there's our answer. We'll do one more division of complex numbers. So we have 1 plus 6i divided by 1 minus 3i. So we got to get the complex numbers out of the denominator, so we'll multiply the denominator and the numerator by the complex conjugate. So after we do that, we'll use FOIL so we can do that. After we use FOIL, we'll start combining like terms. So for the numerator, we'll have 1 plus 9i plus 18 times negative 1 over 1 minus 9. Remember, these should cancel out in the denominator, which have no complex numbers, times negative 1. And that will leave us with negative 17 plus 9i over 10. And since we have to put our answer in standard form, it'll be negative 17 tenths plus 9i over 10. And there's one more example of how to divide complex numbers.